Hello everyone. So from today we're going to start thermodynamics, and we'll cover it in 5 lectures. And this lecture we're going to discuss basic terms of thermodynamics. So start then. Whole lecture sequence will be shared with you and the community post. Okay. So let's start. Basic terms of thermodynamics. First of all, you have to understand what is thermodynamics. So it is a branch of physical chemistry. Okay. Uh, which deals with heat exchange between system and surrounding. System and surrounding. If it is not visible, I am dictating you may write. Okay. So it is a branch of physical chemistry which deals with heat exchange between system and surrounding. What is system? What is surrounding? We will discuss. System, surrounding. See, system is the region, okay, where we are just doing the experiment. This is system. It is the region. It might be open. It might be closed. But it is the region where experiments are going on. And the outside region of system is called as surrounding. And this system plus surrounding, it combines and forms universe. This is a concept of system and surrounding. Now, systems are of two types, very basic: open system and closed system. Okay, in closed system, heat exchange is not as such possible. Open system, since it is open, the contact with the surrounding is there, so the heat exchange is possible. That's very basic, so I'll not take that here. Okay. So the basic system surrounding, which I think you understood. Okay, now we will discuss about more basic and more, you can say, important terms of this particular chapter. So first of all, just let's discuss about intensive and extensive properties. Intensive and extensive properties. Intensive properties and extensive properties. These are very important terms which we'll use in this chapter very frequently. Extensive properties are those which are additive in nature, like you say mass, say volume, you say number of moles. But intensive properties are non-additive. Here also comes Gibbs energy, which we have discussed in electrochemistry. That is non-additive nature, non-additive in nature. And talking about its examples, it can be density, EMF of cell, and all. Okay, so I'm writing example here if it's not visible. Density, EMF of cell, and many more. Okay, these are the two terms which you must understand. Nextly, we have to discuss about state function and path function. What are state functions and what are path functions? Okay, the state functions are those whose work done we'll discuss in next lecture. I think uh, doesn't depend on path. Whatever be the path, there is no any issue. Work done will remain same. Okay. Whether you go by this path, you go by this path, you don't go by this path, it will be same. Okay. So actually we can relate it with some terms which I'll discuss with you. While path functions depends on path, work done of these functions depends on path. So the state function, then we'll treat it as what do you see? In physics, we use the term distance and displacement. So this will be treated as displacement because it is path independent. It just depends on the initial and final position. Work done or any other parameters can also be there. And talking about path functions, it can be treated as distance as it is dependent on different path. If we change the path, then the distance will also change. Right? So these are the two different terms which you must understand. Clear? So now talking about some of the examples. So talking about the state function. So pressure, volume, temperature. These are state functions. Internal energy, like this, we write. Change in internal energy is being treated. Not the, you can say, absolute. Talking about path functions. We have work done, we have heat exchange, and etc. So, because why internal energy is a state function? Because temperature is a state function, and when we will discuss about internal energy, its formulation, then you will see temperature plays an important role, very important role in altering the internal energy of a system. Okay, now talking about what happens at equilibrium. At the rate equilibrium, we write delta of all phi is equals to 0. This delta, this phi, is actually what? It is state function. Like delta P will be 0, delta V will be 0, delta T will be 0, delta U will be 0 at the rate equilibrium. We have to understand. Okay. This is for the state functions, not path function. Path functions. Okay. So these are the two important segments in intensive properties, extensive properties, and that is state function and path function. Okay, I hope you got this very well. And next, we have to discuss about thermodynamics. In this lecture, I think we are done with that. Okay, one more you can say point which we can discuss here in accordance with intensive and extensive property is that there is a note that the ratio of two extensive property is an intensive property. What does it mean? Let's take an example. We discuss. What we discuss about density rho is equals to mass over volume. These two are extensive property as we discussed earlier. And this density is an intensive property. So here from this example it is very clear that ratio of two extensive property is an intensive property. We can take more examples also to understand this very well. Like you can take the example of one term which we discuss in solution small concept, that is molarity and molality. Just take examples. Molarity, what you can see here is number of moles of solute over volume of solution in liters. Both are extensive property, but the ratio is coming as an intensive property. Okay, again molality, number of moles of solute over weight of solvent in kilogram. Again both are extensive property, and this is coming as an intensive. This is the most important, this is one of the most important thing which you must understand. Okay, that ratio of two extensive properties and intensive property. Okay, and I have uh, given you clarification through three examples also. Okay, so yes, this was I think our first introductory lecture on thermodynamics, where we discussed about basic terms which are very useful in thermodynamics, and it will help us in understanding the further thermodynamic processes, thermodynamic you can say concepts, okay, of heat, work, and internal energy. These are the terms. Okay, so I think our first lecture is meant for this also, this only. And in next lecture, what we'll discuss, I'm telling you, I have the planner with you. I've shared with you the planner. So in accordance with that, we'll be discussing. Wait, let me check. Just give me 5 seconds. Yeah, in next lecture we'll discuss about ideal gas equation and different types of thermodynamics process. Okay, so stay tuned for next lecture. Till then, revise this lecture very well. Okay, and you will get this lecture on 28th of April, 4 p.m. slot. Okay, okay. So, let me show you the thank you slide. So thank you for joining me in this session. Bye bye. Take care, and I'm exiting from this uh, window from in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now I've shifted the language from English to English. Okay, due to some reasons. Let's see right now. Okay, so mostly our lectures now from now will be in English only. Mostly, except it is a lecture of uh, where I supposed to be explained in Hindi. Otherwise, I'll take it in English only. So, okay then. Thank you so much. Next lecture we'll discuss about ideal gas equation and the different types of thermodynamics. Thank you.